All right, everybody, Gabe Jenkins back with you from the CCA, the College and Career Accelerator, here in Connecticut, accelerating your future. We are working on SolidWorks part number 9 for class, and you strap in. This one's a lot of interesting stuff going on in this one. It's got a lot of new features that we have not had to use yet, and so I'm really excited to do this one with you. The key things to note here in terms of new tools we're going to use. We're going to use the revolve tool, right? So up till now, everything we've made, that's the three-dimensional shape, involved making a two-dimensional sketch and then extruding it wider, right? Or making it taller or deeper, whatever. Just moving it in one direction. We are going to use the revolve boss base tool, which takes our two-dimensional sketch and it's going to spin it around a central axis. And so we're going to make a three-dimensional solid by rotating around, revolving a two-dimensional sketch around an axis. We're going to learn how to make a new axis. We haven't had to do that before. So in this shape, I want you to be able to make your own axis of rotation. We're going to be using circular patterns. We're going to cut out this one shape right here, and then we're going to rotate it around that same axis, right? So a lot of new stuff to go over in this tool. We're using, just to be clear, MMGS is our units, and the material we're going to be using is mahogany wood. Mahogany wood. Fun fact, right? SolidWorks gives you the ability to manipulate and edit the materials. It's not just because it looks neat or it's cool and it's fun to play around with, which it is. It's really because SolidWorks at a deeper level gives you the potential to do simulations and much more detailed analyses of the products that you'd be making. And so if you wanted to see how a certain metal piece that you're making would perform under pressure or how flexible it is, SolidWorks gives you the ability to really model all of those different stress tests and see how parts perform together or by themselves under different conditions. And so you can edit the material to see how it would do that. Anyway, or if you want to see how heavy would this piece be, anyway, you know what I'm getting at. So the very first thing we're going to do here, we're going to start off just to give you a quick heads up about how this piece was made. Okay, we're going to start off. We started off with a sketch that looked like this. Let me just edit the sketch so you can see what it looked like. We started off with a sketch that just looked like this, and by rotating it around this axis right here, we made that shape, right? So we took this whole we made half of it, basically, and then rotated it around. Next thing we did really quickly was we made a slot, and we cut it out, extrude cut. We then took a third piece right here, cut this it's hard to see, but we cut that piece out. Next thing we did was we made our own axis, right? I made an axis that went right down the center of the material. And then I took that and I cut out, I made multiple cuts. So I spun my cut around that central axis 3 times. So then I had 3 cuts. And then finally I ended up by just making a through hole through the whole thing. So that's what we're going to try to replicate in this tutorial today, right? So I'm going to start off by making a new part. Make sure it's MMGS. I'm not going to worry about the material right now because it's kind of easier to model when it's not in the material because you can just see everything better. And I'm going to start off by making this half of this profile, and I'm going to join it all at the end, right? So I'm going to draw it on let's draw it on the front plane. That makes kind of the most sense to me right now. Again, it doesn't always matter. So I'm going to start off by I'm going to pick this down here as my starting point. I know that the whole thing is 70 units long. So I'm going to go from here straight out. I'm then going to go up. I'm going to go down. I'm going to go over. I'm going to go over. I'm going to go up again. I'm going to go over, and I'm going to go down. Now, none of those are right. None of those dimensions are right, but that's okay because I'm going to go here and I'm going to start dimensioning them. Let me zoom in a little bit so it's a little bit easier to see everything. This one's going to be 70. I'm going to do the longest one first because SolidWorks automatically adjusts everything that you've drawn so far so that the first thing you dimension, that's what fits on your screen. This is going to be half of 40, so it's going to be 20. Okay, This one right here is going to go from here to here is 25. This piece right here is going to be half of that, which is 12.5, right? This, let's see, from here to here is 19. Let's see, from here to here is 47. So from here to here is 47. Let's see, what else do I know? I know that, let's see, that's 19 and that is 47. This must be 28. It knows that. Leave it driven, that's fine. And it does not know how high this part is. So we need to figure out kind of how high this part is right here. Well, does it give me an angle? No, it doesn't. It gives me how far this cut is, but that's not really helping us out. So let's see. Does it show us on a different diagram? Ah, so this is a little tricky. 13. Okay. All right, so in order to figure out kind of like how far down this is and how far down that is, it doesn't give us the dimensions on this view. We kind of have to go over to this view. We look and we see, okay, there's this hidden line here, so there's a feature that we don't see, and that is this line right here, and it says it has a diameter of 20. Diameter of 20 means radius of 10. Right? This feature isn't dimensioned. It's the wider part. It's like this line. So we know that this is 12.5 or 25. So from here to here, this larger circle has a diameter of 25, which is what we modeled here. The inside one, it takes a second to figure it out. This one has a diameter of 20, which means a radius of 10. So if this is a radius of 10, it means that we need to dimension this so that, well, let's mention this. This is 2.5. This is also 2.5. There's only one line there. So now once we've done that, it knows everything it needs to know in order to dimension this. That's awesome. So that's challenging, right? You had to figure out some stuff right there. Now, so far, whenever we wanted to take a two-dimensional profile and make it three-dimensional, we've been using extruded boss base, and it would be something like that, right? And that's not what we want to do, so I'm going to exit that. What we want to do is we want to do a revolved boss base. So I'm going to click on that, and it says, what is our axis of revolution? It means, where do you want to spin it around? I want to spin this one around, this line right there that I made. So when I click on that line, it gives me a shape that looks exactly like what I'm looking for. And that's my first revolve feature that we've had to create. I hope you're proud of yours. I hope yours looks exactly like mine. All right, next thing I said we're gonna do is we're gonna make that little slot cut right there. So I wanna draw something again on the front plane. So I'm gonna make a new sketch, and I gotta look back over here to my dimensions. What does it say? It says, well, it's a slot, which is like an elongated oval, right? But with flat top and flat bottom. And it says that The center of this circle is 4.66 over from the end, and this is 12.66 over from the end. So if I make a couple of little construction lines and go straight over from here, boom, and then boom, and I dimension them and I say, okay, this line here is going to be 4.66. This one's going to be 12. Nope, 8. I'm saying 8 because it's 12.66 over from the edge right there. All right, so now I'm going to make a slot. I don't know if we've had to make a slot before. I don't think we have, right? So we're going to make we're just going to make a straight slot. We know the centers of the circle, so I'm going to click on the center point of this circle, center point of that circle, and start to round it out a little bit. It asks me for some information so I can define it correctly, right? So it's asking me how wide do I want this whole thing? And it's saying I want it to be 5 from top to bottom. So I click that. Awesome sauce. You can see like these little icons tell you what part of the shape you're trying to measure. So we'll see. So I made the two-dimensional slot, and I'm going to say, okay. Next thing I need to do is I need to extrude cut that out. So I'm going to extrude cut. I'm going to say I want it to go not in just one direction. I want it to go through all in both directions. And I'm going to hit, does that look right? That looks right? Awesome. And say, okay. So now I got the hole there. That is the next part that is made. Okay? Okay. Next thing we're going to do is, I said we're going to cut out a part of this that's going to be just like one of these little one of these slots that I'm going to cut out right there like that. Okay? So what I'm going to do is I know that it goes 44 deep, and I know that it's 2 wide from top to bottom. So I'm going to make a new sketch on this face right here, and I'm going to say, okay, if it's 2, one in one direction, one in the other direction, I'm going to make a line. I'm going to go from here. I'm going to go, I don't really need to carefully measure it. I just need to make sure that these are all great. All right. Actually, you know what? Well, let's do this. I need to make sure that this and this are equally long. I'm going to dimension this one to say it's going to be 1. And I think at that point, if I dimension this top one, I should just say it's driven. Cool. Awesome sauce. All right. That is the shape that I'm going to cut out. And I need to cut out as far down as 44. So I'm going to go to Features. I'm going to go to Extruded Cut. And say I'm going to cut down not all the way through both, because no, that's not going to work. And instead of 10, I'm going to say 44. So it's going to cut down to that part right there. Does that look about right? That looks about right. All right. So I'm going to say, okay. Excellent. So now I made that first cut. Cool, right? Now I want to make 3 more. I want to make 2 more. So I need to make 3 total. So here's what I'm going to do. I'm going to make a circular pattern of that cut, and I'm going to have 3 so that they're evenly spaced around the central axis. So I want to make a new axis. So I don't know if we've had to do that before. Maybe we have. If I'm here in Features, I can go over here to this thing where it says Reference Geometry. So I can make a new plane, I can make a new axis, a new coordinate system, I can make a new point, which will be helpful in a couple of assignments from now. But for now, I'm going to make an axis. And it says, where do you want this axis to be? And I can either like randomly select 2 points and find those 2 things, and it'll just make a line between those 2 things. I'm going to pick the intersection between 2 planes, because the intersection of 2 planes is going to be a line. Okay? So I'm going to say intersection between 2 planes. Click that one. Now the 2 planes I'm going to pick, expand this. I want it to be the intersection between the front plane and the top plane. So that is now, you can see it. It's running down the central axis of my shape right there, exactly like I want it to. That axis looks right, so I'm going to hit OK. Right? So now I'm going to take my feature here, my cut extrude feature, and I'm going to mirror it. Oh, no, I'm not going to mirror. Don't do that, Mr. Jenkins. I'm going to take my cut extrude feature. I'm going to not linear pattern. If you go down here under linear pattern, you're going to see circular pattern. So circular pattern, I don't want 6 of them, I want 3 of them. And when it's asking me up here, what's my axis that I want to spin it around? I'm going to click on my central axis here. So Doing that, hopefully this will work and it won't give me any error messages. If I hit click, I've now cut 3 of them out of my central shape. All right, looks pretty awesome, right? One more thing to do is I need to cut out that central hole. When I look over here, it says that my diameter is, my central hole that goes all the way through, is 13. I'm almost done, but I'm not quite done. I just realized I need to do one other thing first. So I'm going to make a new sketch on this face, and I'll make a circle, central, and I'm going to make a diameter of 13. And I'm going to make it a through hole, so I'm going to extrude cut all the way through all in that direction. Okay, and if I turn it here, I should see the whole thing. Now, it's almost done, but I notice right here it says all fillet radii 1 unit, so I need to go back and figure out where were their radii. Well, it looks like the only radii here are going to be right here and right here. So in order to do that, I got to go back into my original first sketch. It's not a problem. Sometimes it ends up being a problem. This time it's not. So if I expand my revolve, and then I go back into Edit, Sketch, I realize that I needed to fillet this corner and that corner. So I'm going to go back in here to Sketch Tools, Sketch Fillet. My fillet is 1. And it says, what do I want to fillet? And I want to fillet that one and that one and that one and that one. Okay? Now as soon as I click here, it should rebuild the entire thing with the fillet all in revolve dimensions. It should work out, and indeed it does. So there we go. Material, now I'm going to make it into mahogany. It is not a steel, it is a wood. Mahogany wood, look at that. Apply. Close. And it is done. I hope a couple of things, right? First, revolve boss base feature that we've had to make. Super fun to make shapes that spin around a central axis. We had to make our own axis here. Super fun that we were able to do that. And then we realized that we can make a feature and then make a circular array. Make whatever feature it is, whether it's a 3-dimensional like solid feature or whether it's a cut feature, and we can replicate that feature around a central axis. Awesome stuff. I hope you had a great time on this assignment, and moving on to the next one. All right, everybody, have a great day.